A vector has a magnitude and a direction. Two vectors can be multiplied using the cross product. The cross product of two vectors is another vector that is at the right angles to both. The magnitude of the cross product equals the area of the parallelogram with vectors u and b for sides. We can calculate the cross product by this way, letting u as the magnitude of the vector u and b as the magnitude of the vector v, and theta as the angle between u and b. So the length is the length of the u times the length of the v times the sine of the angle between u and b. We can also assume that the equation is equals to the magnitude of the u cross product of b. The magnitude of the cross product of u and b yields the area of a parallelogram with adjacent sides u and b. We have assumed that the angle between them is no more than 90 degrees. This same formula can be used to compute the area of a triangle with adjacent sides defined by u and b. The area A of such a triangle is given by area of a triangle is equals to 1/2 magnitude of u cross product of b. Since a parallelogram consists of two triangles of equal area that share a side. It's time to apply the knowledge that we have learned by doing a problem solving. Finding the area of a triangle using the cross product method. Find the area of the triangle with the vertices P, 1, 3, -6, Q, 0, 0, 0, and R, 2, 3, 1. Objectives in the following problems with three given vectors is that we need to subtract the second and the third vertices to the first given vector. Apply cross product to the difference of the vertices in P and Q with the difference of the vertices with P and R. Then get the magnitude of the cross product, apply the formula of the area of the triangle, and then conclude the problem with the solution.
Here, I will demonstrate how to get the area of a triangle with given vertices. First, we will have to calculate for PQ and PR. What does this mean? This means that we need to subtract this and this. So, we get the values -1, -3, and +6. And then PR, we get 1, 0, and 7. After that, we will have to cross multiply PQ and PR by using this. Here, I will be using the basket method. So, first of all, in the basket method, we will be multiplying diagonally, then subtracting what we are gonna multiply diagonally upwards in the next part. So, first of all, we're gonna get 21i plus 6j plus 0, but we don't need to write that, and subtract -3k and -7j. In this equation, we're gonna get 21i plus 13j plus 3k. The next step is we're gonna get the magnitude of this equation. So how to do that is you square root then 21 squared plus 13 squared plus 3 squared. In this we're gonna get square root of 619. So, applying the basic formula for a triangle, 1/2 base times height. But this time, as our base and height, we're gonna use a different equation. We're gonna use the magnitude of base cross multiplied to height. So, this, we got a value of square root of 619. We're only gonna need to multiply 1/2. So the area of the vertices is square root of 619 over 2.